Hi, so this is the last video, part 3 of 3 for COMP345, slide set number 2. This is covering slides 51 to 69. I'm starting with talking about the smart pointers, and then we go in talking about strings. So here we go. Strings, smart pointers. Okay. So we were talking about pointers earlier. Pointers can be tricky. They can be error prone. There is such a thing that's called smart pointers that allow you to, alleviate some of these problems that are related to pointers using what's called smart pointers. I'm going to give you a brief introduction to smart pointers. If you want to use them, fine, but you have to know what they mean and how to use them. Yes, it leads to have a less error-prone use of pointers, but you still have to know how to use them, of course. So smart pointers basically will allow you to avoid many of the memory leaks problems that you may encounter if you're using regular pointers. It will also allow you to avoid some of the dangling pointer issues that are related to regular pointers. So they are in fact very useful to avoid some errors. It's important also to realize anytime you use some more user-friendly features of C++, such as smart pointers, it actually leads for your program to consume a little bit more memory. So if you want to have a very lean use of pointers, you should not use smart pointers. Not that it consumes a lot more memory, but it makes the compilation process more difficult. It's somehow you have to know how to use them, especially if you make some mistakes at compile time. It can lead you to be faced with very cryptic errors because smart pointers are using templates, which we will cover much later. So smart pointers allow you to reduce the amount of bugs that you may have as you are creating your program. They somehow retain the same efficiency. They use smart pointers using the same syntax as you use regular pointers. So what they do is essentially it's a pointer. It's a data structure. A smart pointer is a data structure which is implemented using a template that is making its own memory management. Okay, so if you create a smart pointer and you use new to make the pointer point to a certain value, as this pointer goes out of scope, then it's going to call the destructor of this template, which is itself going to call delete automatically. So that you can call new using the smart pointer. You don't have to care about calling delete. The template is going to take care, the class that is generated by the template is going to take care of calling delete every time a smart pointer goes out of scope. That's how it actually achieves that, reducing the number of the bugs in memory allocation. Okay, so smart pointers are smart in that they do some of the memory allocation for you automatically. There are different kinds of smart pointers. There's auto pointer, which used to be the first smart pointers that you had in the earlier versions of C++. Auto pointer is now deprecated. You can use it, but you're going to have some warnings if you use them. And there's a unique pointer, shared pointer, and weak pointer. I'm going to show you here how auto pointer is working. The other ones are working very similarly, except that they have a specific usage. For example, that if you use a unique pointer, a unique pointer, smart pointer, you would not be able to have two smart pointers that are pointing to the same value. So it implements a additional restriction. Okay, so not going to go into the details of all of the different kinds of smart pointers. You should do your own research and figure out which one is more appropriate to your own usage if you want to use them. You don't have to use them, but they can be making you avoid some of the problems related to pointers. All these smart pointer templates are defined in the memory library. So if you want to use them, you have to go #include memory. So here is the template. Again, we're going to cover templates later. A template is essentially some kind of class that you define that is defined independently on a certain type that is being used by this class. For example, here this defines a template called auto pointer, which defines a class template. And then it allows you to have a pointer that is a pointer to any type. Okay. Again, you don't have to know the details about templates at this point, but just know that this is using a template. Then you also have inside of this template defines a template for a class, which has an explicit constructor. That means basically you cannot, this constructor cannot be used in a type conversion sequence, okay, as we saw earlier. Then you have a destructor for the auto pointer class, which essentially when this destructor is called, it will delete the pointer. Thus, anytime that the variable, which is of type auto pointer, goes out of scope, it would call the destructor, which in turn would call delete, which makes it so that you don't have to yourself delete this pointer. It also implements the operator star and the operator arrow that allows you to dereference this pointer, which is actually returning the dereference pointer. So all this to say that the smart pointers are implemented using templates. They all implement all these operations that are normally available to regular pointers. So how would you use that? So let's say you have a program here that's creating a pointer to an object of type myClass. This is here calling the copy constructor of this class to instantiate, to initialize this variable that is being pointed to by this pointer. Then you make this point, you use this pointer to do something, to call a member function called do something inside of this object of type myClass. And then if you use a regular pointer, you should not forget to delete this pointer here, or else you're gonna have a memory leak, right? If you use an auto pointer, then all you have to do is to use the template auto pointer using the angle brackets here that specifies what's the type of value that is pointed to by this auto pointer. And then you provide your initial value for this that is pointed to by this auto pointer. It is still going to call the copy constructor and so on. Then you're going to have an auto pointer that points to this value here that was created here. Then you can do the same here. Use your auto pointer to call to you to refer to some members of this object, just like for any other pointer, except that when this pointer, when this auto pointer goes out of scope, the runtime system is going to automatically call the destructor of this auto pointer object, which is going to call delete on the pointer that is inside of the auto pointer data structure, which is going to free the value that was pointed to by this pointer. So here, basically, the effect is that you don't have to call delete. It's done automatically for you by the definition of this template. So, of course, the problem here is that one of the problems that you may actually have dangling pointers. If you use auto pointers, then it will actually avoid some of these problems. So how does it do it? It's by actually implementing automatically the assignment operator. And you see that you have a specific assignment for the implementation for the assignment operator that avoids some of the problems that may be related to if you don't use an auto pointer. So essentially, the auto pointer implements a lot of the mechanics that you would have to do manually if you would not be using an auto pointer. Okay, and so that's what you have to know about using auto pointers. There's some things happening behind the scenes that is making your life easier. Okay, if you don't use auto pointers, then you would have to do these things manually yourself every time you use a pointer. Now, another topic that I want to introduce here is when you the parameter passing schemes, and the schemes for also the return value, the value returning schemes, using either values or using references or using pointers, because you can pass by pointer, you can pass by value, you can pass by reference. As we saw in a previous example, you can also return by pointer and return by reference or return by value. All these three different things, the different parameter passing and returning, value returning schemes, each have a different semantics or meaning. So it's important to know what's mechanically what's happening when you pass by value or by pointer or by reference. So when you pass by value to a function, effectively what's happening is that the value is being copied. So if you have a certain value in the calling function, you pass this value to another function, a copy of this value is made, and then that's the copy that is being passed and used by the called function. So in effect, of course, and if it's a copy and you alter the value inside of the called function, you are not changing the value in the calling function. So that's what's the meaning, the mechanics of, or the definition of pass by value. That's the implication of passing by value. The implication being that if what you are passing is an enormous value, then anytime you're calling a function that passes by value, you would make a copy of this very large object, okay, which consumes potentially a lot of memory. So if you want to avoid consuming a lot of memory when you pass a large value to a function, maybe you would rather pass by reference or by pointer, which would only, if you pass by pointer, would only copy the pointer value and pass it to the function, avoiding to make a copy of the entire object. So from this perspective, pass by pointer and pass by reference is the same. But as I said earlier, the difference between passing by pointer and passing by reference is the fact that a reference is an alias to what is being passed. Whereas if you pass by pointer, you in fact copy the pointer value and you pass the copied pointer value into the function. Whereas if you pass a reference, it's just basically an alias to the value that is received is in fact a reference or an alias of the value that is being passed, okay? So that's two examples. I'm not going to go into all the details here in the lecture time about these examples. Please go to the labs, the videos, and go to the labs if you have some questions about these examples, which are available on the website. There's plenty of examples available for this slide set number 2. So basically here what I'm doing is I'm creating a class here named C, and then I'm passing either by value or by reference or by pointer, I'm passing this object C that I'm creating here. So if I pass by value, then a copy of this object C is made as the function is being called. in terms of an object, if you pass a value, if you pass by value, it's going to call the copy constructor, which is this one here. So if you trace the execution of this program, you will see that as you pass by value, it is going to print out this, which is an indication that the copy constructor was called. Okay. So that's a very typical way that I do to do my examples. I would somehow instrument, put some code that is outputting something that allows you to observe, mechanically speaking, what happened. So in this case, if you pass C by value, it's going to make a copy, and how it makes the copy is to call the copy constructor. And you're going to see when you pass C, it's going to print out this here, indicating that the copy constructor was called. So very often you will see some of my examples, many of my examples are going to use this kind of thing to show to the console what is it that actually was called. If you pass by a reference, you will see that there's no call to the actual copy constructor. If you pass by pointer, no copy constructor is being called. Why? Because when you pass by pointer, it's the pointer value that is being copied. Pointer value is not the value itself. The pointer value is the memory address that is stored in the pointer variable. That is what is being copied and passed into the called function. The object itself is not being copied, hence the copy constructor is not being called. Then I do the same here, and so basically I created 3 different functions which are listed on the following slides. That's strictly for passing values. Here you also have returning. Same thing goes if you return by value. For example, this function here, pass and return by value. If you look at its code, it's returning an int, or it's returning an object of pass and return by value. You see that it receives an object of type C and outputs an object of type C. So what's going to happen if you pass an object of type C to this function? It's going to call the copy constructor to make a copy of the passed value of type C, make a copy, and that's this copy that's going to be used internally inside of this function here. And when it returns, the same is going to happen, because if you return an object of type C, it's going to copy this value that's being returned, and it's the copy that is going to be used inside of the called function. If you pass by pointer, then what is copied is the value of the pointer. If you return a pointer, then what is copied is the value of the pointer. Okay. This is problematic if you return by pointer, if the pointer that you return is actually a value that is, or the value of a variable that is local to your function, and you return a pointer to it, then you're returning a pointer to something that was locally assigned inside of this function here. So if it goes out of scope, then something is likely to go wrong here, because you return a copy of a pointer that was pointing to a locally assigned variable. As far as returning by reference, if you remember some of the previous example I shown when I was talking about references, returning references is something very special that is used, especially as we will see when you overload your stream insertion operator. If you want to have a series of stream insertions, your stream insertion operator must return a reference. So that's mostly how pass by or return by reference is being used. Again, here I'm not going to go into all the details of this. If you want to know all the details, go to the lab, the video, and the lab instructor should give you some more detailed explanations of these examples. If you still have some more questions, go to the live session for your lab. Now the next thing, or the last thing here, is the strings. So strings, there's a lot of different ways that you can actually use strings in C++. there's the C way of using strings, which anybody would agree that is a very low level and quite error prone. Okay, so I'm going to give you some examples, which are going to be some kind of counter examples showing you that it's problematic. Okay, using C style strings, which is essentially a string in C is an array of characters terminated by \0. So it has some libraries that allows you to, for example, extract a substring, concatenate strings, and so on. It has all kinds of free functions that you can use to manipulate strings and create strings. But if you don't know exactly what they are doing or how they behave, you can actually run into a lot of trouble. So I'm going to show you how you can use them, but I would highly suggest that you use the string class, the C++ string class, and possibly refrain from using the C style strings. Why am I mentioning them? Because if you are working with pre-existing code, legacy code, very likely that you're going to see C style strings. So that's the only two things I'm mentioning here about strings. That's not to say that that's all there is to it. There's C style strings, there's a string class of standard C++, there's MFC strings, there are a lot of libraries define their own string classes. They're all different, even though they are similar, okay? So there is a lot of different ways you can actually program with strings in C++. So here's showing you some very brief introduction about C-style strings. So what is a string in C is essentially an array of characters that is terminated by the special character \0. Okay, so any of the functions, for example, strcopy, why do you have \0? It's because if you call this strcopy, which is copying a string, if you look inside the code of strcopy, it's basically going over the array of characters, and it's looping using pointer arithmetics, and it's basically copying every character one after the other until it encounters the character \0. This \0 here is central to the execution of most of these functions here. It's basically a stopping point for the a special character that specified this is the end of the string. Okay. So even here, there are two different ways to put hello in a string. These are two different ways. Here, you don't have \0, but if you use this way, it's essentially gonna put \0 for you, okay? So even though you don't put it yourself, it's gonna be there if you do this here. So the C string library, which is a C library, is providing you with a lot of different functions. For example, copying a string from S1 to S2, concatenate a string S2 into S1, the length of a string S1, compare two strings S1 and S2. For example, if you, strchr is, you feed it a certain character, so it's going to tell you what is the index of the first occurrence of this particular character in the string S1. str is doing kind of the same except for a substring. It's going to give you the address of the first character of the first occurrence of a substring inside of another substring. So yes, you can use these here, but then you would have to use the C string C library. You can use them, but there's a lot of pit traps in using them. It seems simple, but it's not that simple. If you don't know exactly what you're doing, you're going to run into problems. And that's what I'm exemplifying here by these examples here. If you go to the examples in the lab, you will find more explanation in the code, and lab instructor should give you some more explanations about what are the problems related to these problems in this code here. So even though it might seem when you read this code that it's clear that it should be doing what you expect, there's particularities of C strings that are puzzling. Okay. So you might think you're doing something simple, but if you don't understand exactly how it's working, you will run into problems. So that's why I propose that you use the string standard C++ library that provides you with a string class. So these are all the members of this class. So the string class is essentially a class that provides you with a lot of members, which are it's very handy. However, this being handy comes with a price. That actually means that when you declare a string of the string type of the C++ standard library, it will consume a little bit more memory than a C-style string. Okay. Anytime you have something that is more handy, that is providing you by a C++ library, you always have to assume that there's a cost for it to be more handy. The string object that you're creating not only will contain the string itself, but it will contain other things which are consuming more memory. For example, like the length of the string or things like this. Okay. This class provides you with all kinds of things. For example, the assignment operator, the size of the array, size and length is not the same because you know it's possibly you can increase the size of the string. If you're using a C string and you want to change the size, that can be problematic. The string class allows you to more easily be able to change the size of a string. Not so for a C style string. Or so it provides you with all kinds of other things, including, for example, the string extraction, the extraction or stream extraction operator, stream insertion operator. If you want to concatenate two strings, you use the plus operator, which is very handy. Anyway, so it provides you with a lot of very handy machinery. So if ever you will have to use strings, strongly suggest that you use the string standard library. So this is basically an example of code. Some of you might see that it looks like pretty much what you do in Java. For example, using the plus operator to concatenate two strings. Yeah, so you have also the size operator that allows you to know what's the size of your string. You have compare operator and so on. So this is much more usable than the C-style strings. Again, not going to go into all the examples here. If you want to know more about this, if there's something you don't understand, you run the code you don't understand, go to the lab. So that's about it for this very short video. Thank you.